As NASA's solar probes stared into the blinding corona of the Sun, one of the rarest visitors in cosmic history reached its closest point to our star. Its name, 3I Atlas, the third confirmed interstellar object ever observed entering our solar system. But as it passed behind the Sun, something extraordinary occurred. A sudden surge in brightness, as if this fragment of another world had ignited from within. Then, silence. Telescopes lost visual lock. And when the light returned, the object was changed. Scientists called it a perihelion outburst. Others whispered that it was something else entirely. FES wasn't born here. Its path, reconstructed through orbital mechanics, reveals a story billions of years in the making. It came from beyond our local stellar neighborhood, traveling for untold ages through the cold interstellar medium. A frozen archive of alien chemistry and cosmic history. Discovered by the asteroid terrestrial impact, Last Alert System, Atlas, in early 2025, it immediately drew comparisons to the enigmatic Oumuamua and the comet 2I Borisov. Yet, from the beginning, it didn't behave like either. Its trajectory was faster, its coma brighter, and its internal composition stranger. As it approached the Sun, astronomers expected it to behave like a typical comet, the ice sublimating, forming a long, glowing tail. But 3I Atlas had no such tail. No dust plume, no streaming debris, only a faint halo, compact, dense, almost magnetic in its containment. At precisely 0932 UTC, as the object passed within 0.35 AU of the Sun, data from NASA's SOHO and Stereo-A observatories showed a blinding jump in luminosity, nearly twice the expected brightness in a matter of hours. For comparison, normal cometary outbursts unfold over days, not minutes. The increase was blue-shifted, meaning the emitted light leaned toward the higher energy end of the spectrum. This suggested violent energy release, possibly through sublimation of volatile compounds deep beneath the surface. But even then, the data didn't fit. No visible dust was detected. No secondary fragments. No debris trails that usually accompany such outbursts. It was as if the object had exploded from within, releasing energy without, tearing itself apart. When the light subsided, spectroscopic readings from the James Webb Space Telescope indicated something even stranger, a 40-fold increase in detected water vapor in the coma, without the expected trace of accompanying silicates or carbon compounds. To planetary scientists, this was an astrophysical paradox. To poets of the cosmos, it was the voice of another star, whispering in light. Within hours, observatories worldwide were scrambling to confirm the readings. The European Space Agency's solar orbiter registered a spike in charged particles emanating from the same sector. Ground-based telescopes in Chile and Hawaii noted rapid photometric fluctuations, a pattern seen in rotating irregular bodies, but not at such energy levels. Dr. Alina Torres of the Max Planck Institute described it as the most rapid, non-destructive luminosity event ever recorded in a comet-like body. Meanwhile, NASA's Goddard Space Flight Center released a cautious statement. The observed brightening of 3I Atlas remains under investigation. Initial data suggests thermal runaway in volatile layers, but other mechanisms cannot be ruled out. Privately, some researchers speculated about cosmic ray-induced crystallization, a process in which billions of years of radiation exposure could alter the structure of interstellar ice, When heated near perihelion, these crystalline bonds might snap in unison, releasing immense bursts of trapped energy. Others, more cautious, suggested a collapse of a subsurface CO2 layer, suddenly exposing deep pockets of water ice to solar radiation, producing an almost explosive sublimation. Yet none of these models fully explain the absence of dust, the blue spectral shift, or the sheer intensity of the brightening. By the time 3I Atlas re-emerged from solar conjunction, its coma had transformed. The reflected spectra indicated molecular restructuring, compounds, likely modified by intense solar and cosmic radiation. Some even suggested new molecules were formed, transient species rarely seen in natural comets. This was not a mere icy wanderer anymore. It was something that had changed, perhaps awakened, in the fires of the sun. Comparisons were quickly drawn to Oumuamua, which exhibited unexplained acceleration without a visible gas jet, and 2I Borisov, whose hyperactive outgassing defied its small size. But 3DI Atlas was different. Where Oumuamua whispered mystery, Atlas roared, a burst of light that broke the quiet rhythm of cometary physics. As Professor Brian Cox once said, the universe is under no obligation to make sense to us. And in that single blinding moment at Perihelion, 3I Atlas reminded humanity of just that. Today, scientists around the world are still sifting through terabytes of data from JWST, SOHO, and Solar Orbiter. The numbers hold patterns, hints of a physics we do not yet understand. Was the explosion a natural process, or the echo of something older, something designed? Whatever the truth, one fact remains. An object born in the dark between the stars came face to face with our sun, and, for a brief instant, shone brighter than we could explain. Next, the theories and the mysteries. What was 3I Atlas really made of? And could its secret reveal something far beyond the realm of ordinary physics? When 3I Atlas emerged from behind the sun, the data it carried wasn't just a collection of numbers. It was a riddle written in light. A riddle that challenged every assumption we have about comets, interstellar chemistry, and the very boundaries of natural formation. In laboratories and observatories across the world, teams began dissecting the data. The question was simple. Why did it brighten the way it did? But the answers were anything but. The most grounded hypothesis came from thermal physicists at NASA's Goddard Space Flight Center. They suggested that beneath the irradiated crust of 3I Atlas, a fragile layer of frozen CO2 may have acted like a pressure seal. For eons, trapped beneath that layer, subsurface water ice remained untouched. When solar radiation finally reached it, the CO2 sublimated, the seal ruptured, and the water beneath it turned instantly to vapor. This could explain the sudden 40-fold increase in water emission, the rapid luminosity jump, and the absence of large debris fragments. But even this elegant theory falls short. Why was there no accompanying dust or silicate release? Why was the spectrum so unusually blue-shifted? It was as though the event wasn't a chaotic explosion, but a controlled reaction. Another model, proposed by the European Southern Observatory, focuses on the billions of years 3I Atlas spent drifting between stars. In that lonely exile, it would have been bombarded relentlessly by cosmic rays, transforming its surface into a dense, glassy crust, a shield of carbonized material and exotic compounds. When this crust finally faced the sun's heat, the difference in expansion between the irradiated shell and the pristine interior could have caused a massive structural resonance, a rapid chain of microfractures, releasing trapped volatile gases in a single, luminous burst. This could explain the energy release without disintegration and the color shift, as the crust's irradiated molecules fluoresced briefly in high-energy light. To some scientists, this was nature's own time capsule, a messenger carrying the fingerprint of ancient cosmic radiation. To others, it was too ordered, too precise. Spectral data from the James Webb Space Telescope provided another clue. It revealed traces of complex organic molecules, unlike those found in solar system comets. Some of these matched compounds predicted to exist in protoplanetary disks around older, metal-poor stars. This suggested 3I Atlas might have originated in a different kind of solar system altogether, one where chemical pathways produced exotic ices that react violently to even mild solar heating. If true, then every interstellar object that enters. Our system isn't just a visitor, it's a sample return mission from another star, a gift of chemistry, carrying the signatures of worlds long gone. But for a few researchers, even that explanation wasn't enough. Dr. Suzanne Falsner, a theoretical astrophysicist at Lund University, proposed something audacious: the planet seed model. According to her, interstellar comets like 3I Atlas might not be mere debris, but protobiogenic capsules, natural mechanisms of panspermia, scattering the ingredients of life across the galaxy. The unusual spectral lines, she argues, could represent prebiotic molecules crystallized under deep radiation pressure, preserved for billions of years until the warmth of a young star reactivates them. In this model, the explosion at Perihelion wasn't destruction, it was activation. A chemical awakening as sunlight unlocked molecular chains that had been frozen since before Earth existed. Then came the voice that always stirs both controversy and curiosity: Professor Avi Loeb of Harvard. Having already ignited debate around Oumuamua, Loeb suggested that 3I Atlas might not be entirely natural. He proposed that the object's spectral uniformity and non-dusty outburst could indicate a thin, engineered surface layer, perhaps composed of exotic alloys or hyperstable carbon composites. In interviews, Loeb urged NASA to release raw JWST telemetry, stating, "If nature can produce such perfect symmetry and controlled energy release, we must ask, could intelligence have done the same billions of years before us?" While mainstream scientists remain skeptical, Loeb's question resonates with a deeper cosmic truth. Every great discovery in history once sounded impossible. As of now, no single model explains all of the 3I Atlas anomalies. Among the most pressing questions: what lies beneath its irradiated crust? Volatile ice, crystalline lattice, or engineered structure? Why was there no detectable dust trail, despite the massive outgassing? Why did the brightening event occur only once, precisely at perihelion, then never again? And could the energy release threshold correspond to an activation point triggered by the sun's specific radiation? Spectrum: each theory solves one part of the puzzle and leaves another untouched. It is as if 3I Atlas is teaching us to think beyond our current models. In the end, perhaps 3I Atlas is not a mystery to be solved, but a mirror reflecting our own hunger to understand the cosmos. We send probes across the solar system, searching for signs of life and intelligence. And now, it seems, something from beyond the stars has come to study us. Maybe it's a frozen fragment of a long-dead world. Maybe it's a seed or a message. Or maybe it's simply a reminder that the universe is far older, stranger, and more deliberate than we can yet imagine. As physicist Carl Sagan once said, "Somewhere, something incredible is waiting to be known." And so, as 3I Atlas fades once more into the dark, its secrets half revealed, half concealed, humanity watches, waits, and wonders what other messengers are already on their way.